All right, welcome to section 8.1, inverse variation. There are three different kinds of equations we're going to talk about here. Actually, we even can talk about more than that. Direct variation is basically y equals mx plus b, but we change a couple of things. We make b always 0, and instead of having slope, we call this k a constant. So y is equal to kx. This is direct variation. You can also write the equation y over x is equal to k. So what does this mean? Well, the first thing that it means is it means that the line, the graph of this, always goes through 0, 0. Now it can go, the line could go down, but most of the time it goes up this way. So if we have y is equal to 0.55x, we could say that bananas cost 55 cents per pound. So x is the number of pounds, and then this would be the amount of money that you would pay. Now, no one is forcing you to buy bananas at the grocery store, so if you put 0 in, you would get 0 back. 0 pounds of bananas cost $0. 1 pound of bananas cost 55 cents. 2 pounds of bananas cost $1.10, etc., etc. 3 pounds, $1.65. Plus, if you do a pound and a half, you can have some numbers in between. So basically, direct variation is just a modification of the old y equals mx plus b. So b is 0 every single time, and then instead of slope, we call it k a constant. So these are the two equations. So y divided by x is always a constant. In this case down here, if I take y and divide it by x every single time, it's going to be 55 cents. Of course, you can't do 0 divided by 0, but there's the k. Okay, inverse variation has x times y is equal to a constant, or you can divide the x over and you get y is equal to k over x. So in this situation, you're multiplying two numbers together to get a constant. Here, we're dividing two numbers to get a constant. So that's kind of the difference between the two. So this would look like 2 and 4 and 4 and 2 and 8 and 1 and 1 and 8. So what's going on here is if I multiply these together every single time, we get 8. So x times y would be equal to 8. The real world example of this is distance is equal to rate times time. So if it's 20 miles to the next town, Wilmington, we'll talk about Wilmington here, and your rate and time. So these two multiplied together has to always be the same constant constant distance. So what this says is if your rate goes up, then your time goes down, and vice versa. If your rate goes down, then your time would go up. So in this case, we would have something like x and y, or rate and time. So if you're going, let's see, 60 miles an hour, then it'd be a third of an hour, because 60 times 1/3 would be equal to 20. So that's how long, that's the relationship here. So the rate 60 miles per hour, the time would be a third of an hour. Or if you're going 20 miles an hour, it would take you a whole hour to get there. And let's see, any multiplication of those together. I guess if you're going 5 miles an hour, it'd take you 4 hours to get there. So like if you're walking or something, or slightly jogging, if you were going 1 mile an hour, it'd take you 20 hours to get there. So in a car, right, it's a lot faster than crawling on your hands and knees to get to Wilmington. Next, we have combined joint variation. So this would be a joint variation where you have z is equal to k, x, y. So you have two variables relating to one number and a constant holding it together. So this would be an example of this would be like 1/2 base times height. So the area of a triangle, base times height times a half, there's your constant there, would be the area. So two variables are creating the final variable. If you had something where it was joint, so joint this would be a joint variation, but if it was a combined variation, you could be putting these things together. So you could have z is equal to kx squared divided by y. So the way you would read this is you would say that it's directly related, so we're combining these together, so it's directly related to x squared and inversely related to y. So z is directly related to the top, and then the bottom of the fraction, the denominator, it would be inversely related to that. So when it says the word directly, then it's on the top side of the fraction, the numerator, and then if it says inverse, it'd be on the bottom or the denominator side of the fraction. So basically it's taking, by combined, we're taking the direct and the inverse and combining it together. Okay, and then joint would just be like multiplying multiple things together to get a third thing. You have as many variables as you want to. At a certain point, it doesn't really make sense anymore. So in the book, this would be like the sayings that would go with this. Let me focus it again here. And there we go, focus. So here's the words, the English words. Z varies jointly with x and y. So it's jointly on the top. And then jointly with x and y and inversely with w. So x and y on the top, and then w inversely goes to the bottom. And then directly, so jointly has like two things. Then directly just has one. So it's directly with x, and then inversely with the product of y and w. But the k is always on the top of the fraction. I mean, k could be a decimal, which you could write it differently. All right. The main thing in this chapter is fractions and fraction functions. So we're going to focus on this idea right here, this inverse variation idea. So the most basic inverse variation is your basic rational function, and that's y equals 1 over x. So this is a situation where you have x times y is equal to k, like if you multiplied the x over, and the k is equal to 1, so we have x times y is equal to 1. So it is a rational it's an inverse relationship, so you can say it's a rational function or it's the inverse function. And also on the calculator, x to the negative 1 is considered the inverse button on the calculator. Okay, let me move this up a little bit and adjust, refocus. So this is the inverse button on the calculator, like x to the negative 1, x times y is equal to 1, which is x times y equals k, the basic rational function. So the first thing that we notice is you can't divide by 0. So x it cannot be 0. So it creates this boundary at x equals 0. This boundary is called a asymptote, an asymptote. So it's a vertical asymptote. And then when you graph this out, you'll also notice that y can never be 0, so that creates another boundary. Then we can start thinking about points that would go in here. So 1, if I put 1 into here, you would get 1 back, so 1, 1 is a good point. And then if you put in 2, you would get a half back. If you put in 3, you get a third back. So it keeps going down like so and approaching 0 but never hits 0. So I draw this half arrow situation. Then if you go the other direction, like a half, well, a half would go into here, flip it up, and make it 2. So a half would be 2. And then that same idea, a third would be 3. So it curves like so. So that's your basic rational function. And all the negative versions of this are true. So if you put in negative 1, you would get back -1. If you put in -2, you get back -0.5. So all of these are true as well. And it doesn't cross these boundary lines here. So that's your basic rational function. All right, example 1. We are going to put our knowledge to use here and solve some equations based on these different equations here. Is it inverse? Is it direct? Is it joint? And manipulate these equations around. So it says x and y vary inversely. So as soon as I see that and I know that they vary inversely, I have x times y is equal to k. I can find what k is now because the second piece of information tells me that x and y are 8. So 2 times 8 is equal to k, therefore k is 16. Now I know the equation. X times y is equal to 16. Then the rest of it says, what is y when x is 4? So I can just put 4, because once I have this equation, I can tell you, hundreds of thousands of millions of x and y's that make this true. I mean, there's infinitely many solutions for this. One solution, though, that's not true is 0, 0. 0 times 0 is not 16, but I could do, 2 and 8, and 8 and 2, and 4 and 4, etc., etc. And that's what the solution is here. So what's y? Well, if x is 4, y would be 4y equals 16. Divide, y is 4. So that's the answer. But once you have this equation, then you're good. You can tell any x and y you want. Okay, example 2 is talking about an inverse relationship here. We have the number of employees. So if you have 2 employees, it takes 100 minutes to get the job done. And if you have 4 employees, it takes 50 minutes. And what are we doing? We're delivering newspapers. And if you have 10 employees, it takes 20 minutes, and 20 employees, 10 minutes. But if you notice, if you multiply those together, x times y is definitely k. And what is it? X times y every single time would be 200. So it says what models this function? Well, x times y is equal to 200. Then it says how many employees would you need if you wanted to take at most 40 minutes. So number of employees is x, the minutes is y. So if we want number of employees, x, is what we're looking for. 40 minutes times 40 is equal to 200. So we divide, and you only need 5 employees. All right. Next example. Okay, the next example says the volume of gas varies directly with its temperature and inversely with its pressure. So we have a combined variation here because we're combining direct and inverse in the same variation. So I'm going to say volume is V. Just reading this sentence, varies directly, K, with temperature. We'll do capital T for temperature instead of lowercase t, and inversely with pressure. All right, now we are given information and we can now solve for K. The volume is 100 when the temperature is 150 Kelvin and the pressure is 15. All right, so 15 goes in there 10 times, so 100 is equal to 10K. Divide this back over, 10 is equal to K. So now I have the equation, volume is equal to 10T over P. And it says, what's the volume when the temperature is 200 Kelvin? So the volume is 10 times 250 over 20. And let's see, 10 over 20 is a half. So basically I'm cutting this in half. So it'd be 125 meters cubed. So basically, we have inverse is our focus here. The inverse relationship is connecting x times y is k The basic inverse relationship graph looks like this. So as x gets larger, y is smaller. As x gets bigger, y gets, or as x gets smaller, y gets bigger. So it's an inverse situation.